Hello everyone, I am Sangeeta Tarai, Senior Research Fellow in NIT Rourkela. Here I am going to demonstrate the GPR software which is designed by using MATLAB App Designer tool. For that we need to open first MATLAB to see how the software is working. And this software is basically used for GPR application where you can image the subsurface objects, raw data, you can image the raw data. You can read any kind of data, and also you can do the clutter reduction, noise reduction, velocity estimation, migration, classification. There are many applications, many techniques incorporated in that software for different applications. So let's start. First we need to open the MATLAB. It is my MATLAB version is 2023B. If you'll some functions may not work in the previous version if it is designed in the latest version, so have later version of your MATLAB. So I need to let me open the software. It is NIT GPR latest. This is the software. This is my code, design code. I'll show the demonstration of the software, and also I'll show how it works. Okay. Yeah, this is the outer look of the software where you can see different options are there. Here different you can have the control of which frequency you want to work on that. This is you can change according to your applications. This is by default, I have kept this value, so you can change it later. And this is start frequency, stop frequency, also how much frequency step you want to, and how much the FFT size should be. Here the first data option which gives you the import of a B-scan or data, also import of A-scan data, resizing, export, many options are there. As per your application you can do that. For import of B-scan you can import any kind of data set like S2B data set, CSV, TXT. Also you can export the data in form of CSV file or any kind of file as per your requirement. For view also you can see the data plot in frequency domain, time domain, frequency domain. Also you can save that data in any form of you want, as in the text file or Excel sheet or CSV file. Basic handling gives you to remove the clutter part, which remove DC plot or clutter part, equalize, time zero corrections, many applications. In for clutter remove part you have different techniques where average removal technique, SBD, PCA, eigenvalue star PCA. I'll show one example how it works. And also you can use any kind of filter you want, low pass, high pass filter. For imaging and for any kind of applications you can have the velocity of the electromagnetic wave inside the media. For that there is technique hyperlapse fitting. Also next we are working to add more techniques for different applications. For imaging we have Kirchhoff migration, FK migration, also reverse time migration, all that. We are still working on that software. For this is imaging is give you the location of the target, where is the exact location is there, and which kind of target it is there. For that you need to do the classification. Different classification models are there. Different classification models are there where KNN, neural network classification, KNN, decision tree, SVM, many kind of classifications are there. Also for that classification you need to extract some features. For feature extraction there are many features extraction methods are there, where A scan based features, B scan based features. So there is it is coming. A-scan based features, many still we are working to add more features to that. Let me show you one example how it is working. Suppose this is the by default, okay, let it be. First we need to import one B-scan data. Suppose I have CSV data. For example, let me give the input where, okay, we'll suppose we are giving ball data. Suppose there is a metal ball placed in the sand media which is at 20 centimeter depth, and it is in air media. Suppose once from antenna to ball, it is in 20 centimeter, the from antenna mouth to the ball. We are using horn antenna. For that I am taking, this is the B scan data where many A scans are there, so I am selecting this folder. Okay, and see, this folder selected, CSV folder. Suppose with this operation we want to see the plot, time domain plot. See, you can see the B scan data plot. Here the metal ball reflection is there. This is the antenna coupling, and this is for the ground reflection. Yeah, ground reflection and coupling, both reflections are there. This is actually, by mistake it is written air media, actually it is the sand media. So this is the corresponding A scan data. Any kind of A scan data I have taken, 4th position, 5th position A scan data. You can check as per change the A scan data, which A scan data you want to see. Suppose I want to resize the data. Suppose this is full data 800 to 4 megahertz, 4 gigahertz, 800 megahertz to 4 gigahertz. Suppose I want to process the data 1000 megahertz to 3000, which is 1 gigahertz to 3 gigahertz, with frequency step size suppose 20 megahertz frequency step size. So you can see the frequency points also changes, and we are keeping just a 2 pattern, and you can see the plot is little resolution is better. So we have given the inputs and we will resize the thing. Yeah, resize, then we will see the plot, time domain plot. See, you can see the by changing the parameters you can do better have the resolution. Here frequency step we have taken 20 megahertz. Rather than taking all the components, we are taking downsampling the data, and we are taking downsample by 5, I think. Yeah, if we have initially it is 4 megahertz, now we are taking downsample by 5, and you can see better resolution and corresponding A scan data. Here a clutter part also you can visible, and the target reflection is little faded by the clutter. So first we have to do the clutter reduction. For clutter, suppose I am doing average removal. See, this is the average removal data, this is the raw data, and this is the average removal data, where you can see the static clutter part is removed. Also you can see the SBD base clutter reduction. This is the SBD base, RPCA based. RPCA is the with all from all this clutter reduction technique, RPCA is giving better results. So yeah, see, many redundancy information has gone, and also data is very clear in RPCA. Here target reflection raw data and the clutter reduced data. This is the hyperbola, the basic concept, where if a target is buried, the reflection should give the hyperbola structure. This is the hyperbola. This hyperbola is extended from around 10 centimeter to 50 centimeter, but it is not the exact giving the exact location. So for that we need to do the migration, we need to apply the migration technique. Before applying migration technique, we have to do the time zero corrections. So you can apply also filtering, all that. Time zero correction is required to compensate the delay because of the antenna part. Antenna feeding point to antenna mouth, there is a delay part, we need to nullify that part. For that we are applying time zero correction. Yeah, you can see the hyperbola is, this is the exact location of the hyperbola, where around time in time axis you can see 1 nanosecond around it is coming at 30 location. So next we will apply on suppose Kirchhoff migration we will apply. Let's see how it is coming. It's a see that faded hyperbola structure is little bit merged. So in this way you can use this technique for different applications. This software is for this graphics user interface software, where as per your requirement you can change the parameters, you can do any kind of operation as per you want. Also you can do the classification part also. So thank you, this is it.